Welcome and thank you for joining us today. My name is Lichi. I'm one of the organizers for this year's Quantitative Seminars series for the Pont Lab. And I'll start with a land acknowledgement. The University of Washington acknowledges the Coast Salish peoples of this land, the land which touches the shared waters of all bands and tribes in the Suquamish, Tulalip, and Muckleshoot nations. Our lab also acknowledges that we live and work on the ancestral lands of the Duwamish people, the first people of Seattle. And so now to introduce our speaker, Yunzhou Li is a research scientist at Stony Brook University School of Marine and Atmospheric Sciences based in New York. Yunzhou earned her Master's of Marine Affairs at the University of Washington, just across this building at the School of Marine and Environmental Affairs in 2016, and got her PhD from the Ocean University of China and the University of Maine in 2021. Yunzhou's research is focused on using interdisciplinary approaches to seek solutions to sustainable and resilient fisheries and oceans under global changes. Her specific expertise falls into the realm of marine protected areas, international fisheries management, marine policy, and climate vulnerability and adaptations. Her research is driven by management or policy relevant questions and problems at scales ranging from local to global. Currently, she leads projects on climate risk assessment for China's capture marine fisheries in response to escalating concerns about the climate crisis and the disconnect between science and policy. So welcome back, Yunzhou. She'll take questions after the talk. So thanks everyone for coming, and a big thank you to Yunzhou for sharing your work with us. And with that, I'll turn it over to you.
Yeah, of course. Thanks so much, Lichi, for the introduction and inviting me to this seminar. So my name is Yunzhou. I'm a research scientist at Stony Brook University, based in New York. And as Lichi mentioned, I did my master at SMEA at UW, and I did my master with Dave Fluharty. I saw Dave was on the Zoom call, and thank you for joining, Dave and everyone. So today I'm really excited to share what I'm doing over the last few years. So the topic I'm going to give is about climate vulnerability assessments for fisheries social-ecological systems. And this is coming out of our recent project funded by Landfast Ocean Program. So Dr. Yong Chen from Stony Brook University and myself are co-leading this project, trying to understand the social and ecological vulnerability in Chinese fishery. And we do have very interdisciplinary and international research group from US and China, with expertise in climate change, fisheries management, marine conservation, and policy and laws. So the biggest motivation for us to start this project is we realize there's a large disconnect between science and policy in China's fisheries management about climate change. Over the last few years, we have seen increasing discussion awareness about climate change impacts on the Chinese fisheries, and also on the livelihoods, on the food security. But at the same time, there's a very minimal consideration about climate change into the fisheries management policy. So that got us wonder, what is the climate risk in the country's fishery, which is also has a large impact on the global food security. So to dig into this question, we start this project and hopefully can generate some actionable recommendations and solutions to fisheries management in China and other places. So the goal of this project is to incorporate a variety of experience, different knowledge and information, including local and expert knowledge, to improve the understanding about climate vulnerability in the Chinese fisheries management, and also to pave the ways for development of climate-ready fisheries. So what I'm going to cover in this presentation is first, broadly, how we learn from the globe, specifically how the climate vulnerability assessment tool has been applied in a variety of social-ecological contexts around the globe. And then we're gonna get into the details and methodologies we develop for assessing the climate resilience of Chinese marine capture fishery and how we engage with different groups of stakeholders in this process. So now a little bit background of climate vulnerability assessments. If you're not familiar with this concept, it's a very popular tool and very useful that combines both qualitative and quantitative analysis into this tool set. And it helps address a lot of key questions we are concerned about climate change and fisheries management. It touches on like how does climate change affect systems of concern, and the system here can either be natural system or social system, or it can be both. It also addresses a question about like how do inherent characteristics of system might affect the vulnerability and sustainability of the system, and it gives insights into the management. For example, what are the related and targeted actions and solutions that could improve the resilience of the system. There are a variety of definitions about vulnerability. In this project, we use the IPCC vulnerability concept. And this might sound confusing as well because IPCC also has two different frameworks. So on the left, we have the original version of the definition of vulnerability. And here it is characterized as a function of three components: exposure to climate change, sensitivity, and adaptive capacity. And then in the fifth assessment report, this concept is kind of transitions to a more focus on the intrinsic properties of system, and is determined by sensitivity and adaptive capacity. And also the assessment is shifting towards risk-based assessment. So you will see hazards, exposure, and vulnerability altogether comprise this new concept of climate risk. And I'm gonna share more details about this risk assessment in the case study of the China. And now, this kind of framework of CVA provides so much flexibility into the application in the fisheries management, because it can accommodate different management needs and on the ecological component, for example, to assess vulnerability of fish species. And it can also address human dimension of vulnerability by assessing how well the fishing communities are doing. And in the middle, there's also some increasing attention in providing approaches to acknowledge these interactions between ecological and socio-economic components in this assessment. So with all these approaches, we have two high-level questions for this project. What are the key advances and barriers in current CVA applications to the marine fishery sector, and how we can improve the utility and applicability of CVA to the marine fishery sector and also to our project? So we did a global synthesis about those approaches and look at how different scale was involved, how different information knowledge was utilized in this process of climate vulnerability assessments, and published this work last year in Global Change Biology. Also in this project, during the study, we identified three specific tasks. First, what is the available approach, indicator, and framework for developing CVA in various social-ecological contexts? And what is a geographical representation in terms of the scale and the region? Is there any gap? And lastly, we'll want to understand how different information and knowledge work together in the process of CVA. So we did a literature review, identified 65 case studies across the globe. The criteria for us to selecting those case studies is they have to have a very specific study showing how they optionalize the assessment of vulnerability in the realm of marine fishery. So for each of the case study, we assess different elements. First, we want to understand which component of fishery system was targeted, what kind of frameworks and indicators were adopted and utilized, with a spatial scale, what kind of information knowledge was incorporated, and what are their patterns and gaps. So I'm gonna dive right into the results. The first part I'm going to talk about is the frameworks and approaches. So you will see there are a variety of frameworks developed for ecological, socioeconomic, and sociological approaches. But mainly we find socioeconomic component becomes the main focus for CV for marine fisheries, meaning that there are a lot of attention trying to understand the human dimension of vulnerability in the marine fishery. And there's also a tendency in using interdisciplinary approaches to assess not only socioeconomic vulnerability, but also in the ecological realm to see their interactions. And then we further dig into the specific frameworks and approaches that have been used to inform future applications to meet different management needs and also applications in different social ecological contexts. So here we categorize all the frameworks into first based on their definitions of vulnerability and their focus on ecological, socioeconomic, and social-ecological components. And we do have a more detailed table showing all the specific case studies where they will apply to give an idea like what is a big picture, what is a landscape of CVA application around the world. And one thing I want to mention from this table is that, as I said earlier, there are two definitions of IPCC framework of vulnerability. And we do see the older framework of vulnerability still predominates in the applications in the marine fishery sector, while there is much less research input to address the risk-based assessment. Another thing we look at is the indicator, because CVA is a highly indicator-reliant tool. And to understand what indicators are available and how we can better inform future studies to justify their methodological choice, indicator choice, we identify over 200 indicators that have been used around the world for marine fishery. And then we group them into 4 domains: ecological sensitivity, recovery potential, socioeconomic sensitivity, and socioeconomic adaptive capacity. We also show the number of indicators and their frequency in use for all the indicators and domains. So now I'm going to walk you through a little bit about those 4 domains in indicator. For ecological sensitivity, you will see a lot of indicators are involving like biological traits or population parameters like reproduction, habitat, stock status, early life stages. And one thing I want to highlight is that there are also some non-ecological indicators being developed, especially for delimited regions. For example, there are some indicators trying to characterize the stock status based on fish price, distance to fishing ground, and fishery type. For example, whether it's a small-scale fishery versus large-scale. And then for the ecological recovery potential, this is actually the least studied and understood of all the 4 domains. And one interesting set of the indicator under this domain is the governance and conservation. For example, there are a lot of tropical countries using the indicator like number of MPA, the objective of MPA, the local efforts in conservation, habitat restoration. And there is assumption about like those conservation and management efforts can lead to greater benefits to the ecosystem, and that could also increase the resilience of the ecosystem to climate change, which is very interesting in this realm. And then moving to the social realm, those indicators about sensitivity are mainly focused on the reliance on fishery for economy, food, livelihoods. And then we have the last domain of socioeconomic adaptive capacity, which is the most well-studied with over 300 applications of this indicator around the globe. And for those domain, we kind of organize those indicators based on the conceptual framework of Singer et al. In 2018. And you will see there are some, categories involved to characterize and assess adaptive capacity, assets, flexibility, organization, learning, and agency. And we provide more detailed perspective and empirical perspective into this conceptual framework. And we hope this indicator also improve the operationalization of between the assessment and adaptation. So those are the assessment on the methods and scope. We also look at different spatial scales involved in those CVA for fishery. So you will see there are different scales involved, but also we notice there is a very uneven focus across spatial scale. With most of the study, more than half of them are focused on subnational scale. Also, there's an important discovery about the mismatch between management needs and research input. So on the left, we have this table showing, the top research input for CVA by counting the number of case studies by each of the country or region. And then on the right, we have this map showing the national vulnerability level of the country's marine fisheries, which is derived from several global level assessments, vulnerability assessments about the marine fisheries. So this table, this figure kind of shows which country have more urgent adaptation needs. And if you compare and contrast these two maps, you definitely see there is a large gap, especially in the tropical country, where there is a strong need to improve their fisheries adaptation, while the research input is rather limited. And third component for this study is how different information and knowledge have been utilized. So we focus on two types of information. One is the traditional scientific data, such as modeling information, species distribution data, and the other is a local and expert knowledge, which provide very different but complementary perspective into climate vulnerability. And different from our concern about limited involvement of stakeholder or local indigenous information in scientific research, especially in climate research, we actually see local and external knowledge has been a primary source in fisheries CVA. And there's also a trend of using a hybrid of knowledge types, and sometimes it has been termed as knowledge co-production. So knowledge co-production is a very promising tool that can, having a lot of benefits, for example, reduce knowledge gaps by bringing together multiple sources. It can also increase the application of information to management issue, identify potential solutions to climate adaptation. But in the CVA practices for fishery, we discover some challenges and issues. One is the goal for this kind of engagement is not clearly defined. It's not sure how this kind of knowledge co-production would benefit the stakeholders and participants. And that easily lead to some stakeholder fatigue in these processes. And also there's a very limited understanding in terms of how different scientific data and local knowledge play a role in this process and how they work together, how they address the knowledge gaps for understanding climate vulnerability. And for this part of research, the last thing I want to talk about is we also look at the interactions between the three elements we evaluated: the scope, their spatial scale, and their information knowledge input. This also is very relevant to our second part of this project, which is focused on the China national assessment, because we want to understand what approaches are available on this scale and how different information and stakeholder was engaged for this kind of scale assessment. So I'm going to highlight some key findings that are relevant to this project. If we look at these approaches for ecological or the socioeconomic dimensions of fishery, you will see those applications are widely used across different scales, represented by the blue color. And if we look at the social-ecological approaches, most of these practices seem to be focused on a relatively small scale, which is a subnational scale. Well, there is currently no quantitative approach to address, the national level sociological assessments for marine fishery. And similarly, you will see this kind of pattern in knowledge co-production, where most of this engagement happens on a subnational scale, but remains nascent for national or larger scale. So with all this information, we summarize the key lessons learned from the globe. We see there are a lot of advances, for example, like diverse approaches being developed. There's a growing interest in using social-ecological approaches. And also we see there are emerging applications about delimited methods indicator. Also, we see there are a variety of skills being involved in those methodologies and a wide application of the engagement methods. At the same time, there are a couple of barriers. One is there's lack of consensus and guideline for people to choose the right methodology. It's really overwhelming for people, who are new in this field to get into, like what is the right indicator, right methods for them to use. And also, we still don't have a quantitative methods to assess sociological vulnerability on national scale. Spatial scale is pretty uneven, and there's an obvious spatial mismatch between the top research input countries and the countries with a high vulnerability from the global perspective. And for engagement, there's a very unclear goal. There's a need for goal setting and also a clear understanding about the role of different knowledge input in these processes. So with this information, we identify some new research opportunities for this project. One is to diversify the use of indicator, because we see so many linkages between, especially the adaptive capacity indicator and fishery adaptation solutions. So there's an opportunity to strengthen their linkages and to identify what actions might be most effective depending on the results of indicator evaluation. And this indicator also provide a really good asset to benchmark the status of fishery and track the changes over time. And that will be really useful for dynamic management for fisheries. Also, there's a need to strategically prioritize assessment efforts based on adaptation needs. And there's a need to improve the understanding of their role in CV, specifically the data-driven approach and the knowledge-based approach. And now I think this leads to our second part of this project, which is to look at how China is doing in terms of their climate resilience. We did two approaches here. One is data-based approach, and the other is knowledge-based approach. So before getting into details about this part of work, just want to give you a very brief overview of China's fishery. So China has been the world's largest fishing country for many years. According to recent record from FAO, its marine capture fishery, including distant and domestic fishery, produced over 11 million tons. The country also has the largest, fishing fleet in the world with more than 500,000 vessels. The industry also supports millions of employment and livelihoods in the country. So on the bottom, you will see how rapidly the country's fisheries have been developing since 1970s, with this increase of fishery production and vessel number. And what we see from this rapid increase in fishing effort is those negative impacts on China's coastal water, coastal ecosystem, declining stocks. And right now, according to this Cao et al. Paper, roughly 57% of the fish stocks in China are overexploited or collapsed. And on top of those overfishing issue, climate change is becoming a new threat for management. For the last 10 years, we have experienced increasing climate-driven changes, such as warming temperature, red tides in the Bohai Yellow Sea, coral bleaching in the South China Sea, and also frequent extreme weather events like typhoons, storms that reduce fishing hours at sea. Also, there's a recent paper showing a strong correlation between small pelagic fish catches and regime shifts. So this indicates the climate change has been a really important issue for Chinese fisheries management. And we do see climate change is becoming a very popular topic in the national ocean policy. We have some quotes from very high-level policy. For example, this one, China Ocean's Climate Change Blue Book, recognize that the coastal areas are very fragile and sensitive to climate change. And then there are two other recent policy, emphasizing the need to implement climate change adaptation actions for ocean and improve monitoring and assessment of climate change impacts on the marine environment in the next 5 years. But unfortunately, there is still limited consideration about climate change in the sector of marine fisheries. So to pave the way for climate-ready fisheries management in China, we realize there are a lot of knowledge gaps to be filled, such as how does climate change affect China's fisheries, social-ecological system, what are the most vulnerable species in fishery in the region so managers can prioritize their resources and management objectives. What are the strengths and weaknesses of the governance system in coping with climate crisis? And from a bigger picture, how we can better prepare for this new challenge. So we did this database approach, and this work was published last month in PNAS. We have a really great team from US and China contributing to this work. And the objectives of this research is to develop a methodology, interdisciplinary framework to assess climate vulnerability and risk for the national level, and also to identify the most sensitive and vulnerable species and regions, identify the factors contributing to the vulnerability, and the possible areas for enhancing the scientific management and social resilience. So we took a portfolio of approaches, such as literature review, developing databases. We also involve some spatially explicit analysis to understand the climate change impacts, policy analysis, and we also build upon our indicators derived from the first part of this project to assess the risk. The scope of this work is mainly focused on the domestic marine capture fishery. So we're not touching upon distant water fishery. And we focus on 3 marine ecoregions in China: the Bohai Yellow Sea, East China Sea, and South China Sea. This study was targeting 28 taxonomic groups. I'm going to talk about this in the next slide. We also have the social assessment for 11 coastal regions. So for the species selection, this is a very tricky part of this work, because in the yearbook of the fish and landing in China, the categorization is very coarse taxonomically. So we have to identify coarse taxonomic groups from the yearbook, and then we identify specific species targeted in Chinese fishery based on databases, and we also consulted with our Chinese expert group to make sure the species are representative and important for the industry. Also in this process, shellfish and jellyfish are removed from this list because it's very hard to distinguish this on the species level. So with all this engagement and input, we identified 28 taxonomic groups containing 67 species. And now I'm going to walk you through this framework we developed for this research. So first of all, we identified 5 climate hazard variables, and then we use the outputs from climate projection model to see how those factors change over time, like in 50 years in the future. And then we did a spatial analysis to see how likely each of the species might be affected by the potential changes in climate hazards. And this was determined by the species distribution and historical records indicating which hazards might affect the species' general life history. At the same time, we put together a database to characterize the species vulnerability. And I'm going to talk about these indicators in that slide. And with these three information, climate hazards, species exposure, and vulnerability, we come up with this score of ecological risk. And then this risk becomes a fishery hazard to the social realm of the fishery system. And similarly, we determine how likely each of the coastal region might be affected by the potential changes in the fishery resources target. And this is based on their catch composition and catch diversity. And similarly, we put together a database to show their socioeconomic profiles, to give a sense about their social vulnerability, and finally to have a final score of social-ecological risk. So these are the indicators we used for species vulnerability. Most of them were derived from the international review. And also want to mention there are some very unique indicators we developed for this research. One is the temporal overlap between spawning seasons and summer moratorium. So if you are familiar with the Chinese fishery, the summer moratorium is the largest large-scale fishing management measure in China that closes the fishing industry from May to September. And the goal is to protect the spawning season of most of the commercial fishery resources. However, this management measure does not guarantee the protection of all the species. So we want to incorporate this indicator to see is there any species was missing out in this management decision-making. And also we incorporate this indicator about stock enhancement to see how decades of stock enhancement in China might reduce the genetic diversity of the wide populations and how that could affect the recovery potential to climate change. And these are the social vulnerability indicator. Again, there are a lot of indicators are about like dependence. We also highlight, this critical role of aquaculture in the Chinese fishery production, considering its potential to mitigate the reliance on marine capture fishery in these processes, and also consider some governance attributes, learning assets, social organization, and flexibility to change. So I'm gonna give 4 takeaway messages that were derived from this work. So first, the important finding we discover is there's a variety species resilience to climate change. In this graph, we show the vulnerability of each of these taxonomic group by their sensitivity and recovery potential. And then the size of the circle represents their landing volume. And now I want you to focus on these 2 quadrants, the green one and the red one. So the green one means that this species tends to have a higher sensitivity and lower recovery potential, meaning they are more vulnerable to climate change. While the green one means they are doing well, they are less vulnerable. And you will see this clear pattern that those high landing fishery resources tend to be, doing well in front of climate change. And this actually creates a really interesting synergy with a previous study showing China's steady fishery production is primarily supported by a limited number of highly productive fish species like hairtail, mackerel, and Swedish crab. And what we find from this study is those species that have managed to survive the stress of fishing also demonstrate a remarkable ability to adapt to climate change. And they overall have a pretty good resilience to climate change. And there are some, factors behind this finding. For example, they all share pretty resilient biological traits. They tend to draw more conservation attention because of their high economic value. Also, there is a less management interventions such as stock enhancement because the production over the last few years are pretty steady. And since all those high landing fishery resources are doing well, what about those high risk species? So we put together this ranking for all the 28 taxonomic groups based on their risk, and then this number shows their landing percentage. So for example, 28 means the large-scale croaker contribute the least across all these taxonomic groups to total landing. And you will see this pattern that the most of the high-risk taxonomic groups contribute a small proportion to total landings. At the same time, it's really important to acknowledge their cultural, ecological, and socio-economic importance to the fishing industry and community, such as large yellow croaker, which is known as a national fish for its high economic and cultural values, but its landing have substantially dropped, about 90% drop because of overfishing and climate change in the last 2 decades. And now it's considered as critical endangered, according to IUCN. And the sand lance is a cold water species. It's a forage fish across the North Pacific and plays a critical role in the food web structure. And I also want to mention this is not just important for China, but also for other neighboring countries like Korea and Japan. So this implicates a strong need to build the cross-boundary collaboration for fisheries monitoring and management to address climate change. And then we take a further look at what factors are playing in this contributing to the climate risk and vulnerability. So we have this heat map showing the different magnitudes of hazards, sensitivity, and recovery potential. And then here we highlight the major contributors to climate risk, which is represented by the darker color for hazards sensitivity and the lighter color for recovery potential. So you will see the major players are warming temperature, the sensitive early life stages, overexploited stock status, narrow thermal tolerance, and the high sensitivity to acidification. Also, overall, the larval dispersal capacity is very limited for most of the species in China. And at the same time, we see there are other factors seem to not likely to trigger climate vulnerability, such as pH, dissolved oxygen, and chlorophyll. There are very limited research showing there are some evidence and impacts on those marine fishery resources. And most of species seem to be doing well in terms of prey and habitat specificity, and they're highly productive. And another thing we look at is their data quality. So we highlight some data gaps in early life stages, stock status, and also biological responses into climate hazards, especially on the ecosystem level. And then moving to the social realm, we see this regional disparity in climate and adaptation challenges. For example, in sensitivity, we see the southeastern part of China has a much higher sensitivity level, mostly attributed to the high reliance on fishery. And there are a lot of indicators supporting this finding, like there are much higher landing weight, value, employment, vessel number. And as I mentioned earlier, there's opportunity to bridge the gaps between the vulnerability indicator and fishery adaptation actions. So we also give some ideas about what could be the option for managers to take to improve the resilience based on those indicators. And then for adaptive capacity, we see a very different pattern. Now, the northern part of China has a lower adaptive capacity. And there are a lot of factors such as limited monitoring, research input. Also, the fishery incomes is much lower than the southern part of China, low involvement of social organization decision-making, and for the Hebei province in Bohaisi, the fleet diversity is the lowest across the country. So similarly, there are some ideas for management actions. And another thing we discovered from this research, you might also notice some indicators have been showing consistently high score for sensitivity or low score for adaptive capacity. And that indicates there are some common challenges over the country. So for example, we find there's overall high reliance on fish protein, a low capacity for monitoring, very limited involvement of non-governmental actors in decision-making. Also, we look at those provincial management plans for fishery to see whether some critical governance attributes identified in Mason et al. Paper has been addressed in China's fisheries management. And we see there are a lot of missing attributes that are critical for climate-ready fishery management. For example, adaptive decision-making, information sharing, equitable and inclusive governance, participatory decision-making, and also monitoring and evaluation for climate change impacts. So with those regional variations and also the common challenges we find from this research, we highlight the need for not only develop top-down approaches, but also localized bottom approaches to address those local contexts and specific challenges we find. And for the last few minutes, I'm going to talk about our engagement with stakeholder. So we develop another approach that is knowledge-based. And the key question we want to answer is whether this approach will generate different or similar conclusion about climate vulnerability. And we think this is a very interesting question, especially for China, because in the past, most of the decision-making for fisheries management are highly dependent on expert knowledge. And we want to see if there's any room or improvement that we can incorporate scientific data, local knowledge, and expert knowledge in this process. So, last year, we developed 2 surveys. One is expert survey, including fishery managers, policymakers, and scientists. And the other is a fisherman survey through interviews. And you will see we cover some similar questions. For example, their general perceptions about climate change and their impacts on fishery, their perceptions about the fish vulnerability, how they score, how they use information for scoring. Also, their opinions about the social vulnerability of their working regions, or the communities they are familiar with, and their feedback and suggestions about management and adaptation. So I want to quickly talk about some preliminary findings we learned from these 2 surveys. We recruited 33 experts all over the country. And overall, we see there are very mixed perceptions about climate change impacts. Most of them thinking the impacts are negative, and also 20% of them have no idea about the climate change impacts. And also in terms of management priority, we see there are different opinions. Like most of them would think climate change is important, but it should be incorporated to medium to long-term management objectives, while some of them, especially those that think the impacts are negative, they think it's really important to take immediate actions in the near term. And also there are a small part of people thinking climate change is not important right now. This seems to be consistent with those positive impact responses we learned. So for the next step, we want to further dig into this question about what kind of makes their opinions so different. So we have some hypotheses like their research background, their location, how they use different information for their judgment, like from their personal experience or engagement with local fishermen, what is their criteria for scoring. So we hope to develop some correlation analysis to assess their relationship. And then for the fishermen survey, we find there are we recruited 24 participants from 5 fishing communities in the Yellow Sea region, and this region is also recognized as high risk for the social-ecological risk score. And this group of fishing communities mainly target mantis shrimp, swimming crabs, cuttlefish, mackerel, sunlance, and some of them are also identified as high risk to climate change. And similarly to those perceptions from the expert survey, we see there's very contrasting views and awareness about climate change by communities, but overall they express some concerns and their observations about changes such as warming temperature, increased extreme weather that limit their fishing hour, sea level rise, algal bloom. And in the water, they also find there are less fish, smaller size in coastal water. But it's very difficult for them to distinguish whether it's because of overfishing or climate change. I think that the biggest impression I learned from this survey is that they all share insecurity about this increased uncertainty in fishing. They are not very optimistic about the fishing industry. None of their children are involved in this industry. Also, they seem to have very high reliance on fishing. They support a family of 4 or 5, and most of them haven't changed their fishing locations or target species over the last 10 years. So I think this evidence and knowledge provides really important evidence and lay the groundwork for policymaking to understand how critical it is to develop adaptation for those fishing communities. So for the next step, we are going to use some quantitative methods to compare and contrast the results. And I know a lot of you from this audience have very strong quantitative background and have some experience dealing with the social data. So if you have any suggestions, please reach out. And finally, I want to wrap up my presentation with this really valuable and interesting responses from expert survey. We asked those policymakers, experts about what are the key barriers to incorporate climate consideration in China's fisheries management. And on top of the list, we see the biggest barrier are limited data, limited understanding about climate change impacts. There's also lack of technical support for decision-making to understand how they can prioritize the resources and management objective. So I think this provides a really good justification about our project because we incorporate so many different knowledge sources, also presented international experience in dealing with this kind of challenge in management. So we are really looking forward to see how our results and finding may shape the policy and research directions in China and other places in the next few years. So with that, thank you all for listening in your time, and I want to thank my co-authors and collaborators. Yeah, I'm happy to take any questions in the next few minutes.
Can you hear me? Oh, okay. Yeah, thank you. That was very interesting. If folks have any questions, feel free to post it either in the chat or in the Q&A section. I guess I can start us off with, I have a very big picture question, which is kind of, where do you see this work going? In a sense, like I guess, where would it need to, who would it need to reach in order to change policy, or China's fishing policy? Where would this information need to go?
Yes, that's a really great question. Thanks, Li. Yeah, so as I mentioned, we have an international advisory committee for this project. We have 3 members from the US and 3 from China. And those members are from different regions like Yellow Sea, East China Sea, and South China Sea. And they have a lot of expertise in Chinese fishery and also a strong engagement with policy making and decision making. Some of them play an advisory role in the central level fishery pilot design over the last few years. So we are really hoping to, reach to the target audience through them. And also, I'm not sure if you are familiar with the Marine Fisheries partnership that we are leading since 2016. So we host like study tours. We bring the Chinese fishery managers, decision makers, sometimes from central level and the provincial level, and we take them to different country, different region, such as US, EU in 2017. And I think this year we're going to Japan. So the idea is to expose them to different management regimes in different countries and see what are the opportunities for China to pick up those lessons and develop their unique, management approaches. So we're also thinking about embedding this research into the study tour design because, for Japan, climate change is a really important issue for them as well. And I think this will be a really interesting mutual benefits for both sides in China and Japan, and really hope to see there's some interesting discussions over there.
Thank you. Okay, I don't know if you can see the Q&A. We have a question from Alberto Rovellini. He says, thanks for your talk. Who were the users that identified climate change as having positive effects? And did they provide some examples of those positive effects?
Yeah, that's a question we have as well. So we haven't dig into those responses because it's an anonymous questionnaire. They don't provide very specific examples about those positive impacts. But our thinking is that we want to see how they have this kind of judgment, because we did ask them some background information, such as where they work, which kind of working region they focus on, which kind of fishery they target, and like their research background, their expertise, whether they have any involvement, engagement with fishermen, what information supports their judgment. So we want to find some clue over there. But yeah, we're also will be interested to see how that conclusion was made.
Dave, you've got your hand raised. I can allow you to talk if you want to go. Okay. Yeah, you're allowed to talk now. I think you can unmute yourself if you'd like.
Hi, Dave.
Maybe, maybe not. Okay. Dave, feel free to unmute when you want. In the meantime, we do have another question from Zilin Chen. Says, thanks for the presentation, Yunzhou. For the takeaway number 1, species that manage to sustain high fishing efforts are also more adaptive to climate change. From my knowledge, these species are also prioritized in the quota management, example 2018 to 19 TAC pilots. What should China's policy do to better protect those species that are more vulnerable to climate change?
So to my knowledge, there is no action implemented right now to protect those species for climate change. Yeah, but I think that will be a really interesting thing to look at the TAC design, because we're also working with EDF, Environmental Defense Fund, to talk about the ecosystem-based TAC design for the Bohai Sea. And also the Bohai Sea is identified as the high risk for climate change. So we want to see how we can incorporate these findings into, the experiments of region-wide TAC in the Bohai Sea. Yeah, I'm not sure if I addressed that question.
Yeah, Zilin, feel free to follow up. Dave, you can talk if
Okay, I'm unmuted.
yes.
Thank
Hi.
you, Yunzhou, for the wonderful talk. I'm intrigued by the potential to extend your analysis to China's distant water fisheries. I think that would be, I mean, consistent with China's growing capacity for contributing to global science of fisheries. China also has a major interest in the success of maintaining those fisheries. And so I'm thinking that work along what you're suggesting for domestic could be applied to the distant water fleets. I'm curious about your thoughts about how that might be done.
Yeah, we are not touching upon distant water fishery because it's kind of controversial and sensitive to deal with. Yeah, so that's why we focus on the domestic. And also, I think it is most closely linked to the domestic fisheries management because we have so many transformations and reforms since 2017. So I think that is also a response to the management needs in China because they have been thinking about how we can incorporate science into decision making. And I think this will be really relevant to their needs. But yeah, I think distant water will be also interesting to explore. And thank you for your question. I would love to see how that would develop in the future.
Thank you.
All right. I guess if we have no other questions, we are at time. So I want to thank you again, Yunzhou. That was really great, and thank you everyone for joining us today. We hope to see you next week. I think it'll be Noble Hendricks from I think Cada Consulting. And he'll be talking about a finite mixture approach for mixed stock analysis. So tune in for that. And with that, yeah, thanks everyone. And thank you again, Yunzhou. It's good to have you back.
Yeah. Yeah, thank you, Lichi. It's great meeting you here.
Yeah. All right.
Yeah. Thank you, everyone. Bye.
Thanks, everyone. Bye.